Good afternoon, everyone. Welcome to JavaScript and Friends. My name is Russell Skaggs, and today I get to talk to you a little bit about building a CSS architecture. So let's start off with a little about me. I've spent about a decade in front-end development. About half that time has been in agencies. The other half has been working for enterprise or consultancies. And most of it's been focused on CSS and design systems in particular. So what do I know about you? Not a whole lot. Dev conferences are kind of a diverse bunch. I know that you came to a JavaScript conference, and yet you attended a CSS talk. But I'm guessing part of the reason that you chose to attend the CSS talk is because CSS is still one of the more difficult things to grasp when it comes to front-end technologies. And a lot of you have probably dealt with a lot of bad CSS. So let's start off by talking about some bad CSS. So bad CSS is one of those things that almost feels intrinsic. You know it when you see it, yet in a lot of cases, it feels more common than good CSS. Usually when you think about bad CSS, you think about situations where it is hard to track down where a style is getting applied. You see a lot of ID and important patches to fix later. You might notice that inline styles have become a bit of the norm. And you can't really tell what changes might cause a break in the system. So bad CSS is very problematic. Part of the reason it's problematic is because it increases technical debt. It is very prone to visual defects. And probably the worst sin of all is it's going to cascade into more bad CSS. For one of my recent jobs, when I came on, I was met with a team of very talented full-stack developers. These guys were in charge of building applications that were customer-centric and were dealing with really important, sensitive information. Yet these awesome rockstar developers spent most of their time dealing with what felt to be trivial CSS bugs. So what causes this sort of bad CSS? And why would CSS get so bad that your talented full-staff development team has to spend so much of their precious time working on that rather than focusing on important business-critical features? Well, there are certainly some organizational challenges. Rushing to meet tight deadlines and unexpected changes that would happen to the design. In many cases, this was a case where several simultaneous projects and features were modifying the CSS. Different developers had different coding preferences. And that became problematic because, unlike the rest of the architecture, the CSS was not held to the same standard as real code. And that's been a common theme throughout the beginning of my career, and even trying to make the case for strong front-end developers before big frameworks like React, Angular, etc. caught on. CSS is real code. And even though a lot of people may think it's easy because of how easy it is to write, people often forget the maintenance factor. So let's start off by asking a question. How well do you know CSS? There was an interesting question that Max Stoiber asked on Twitter a few years back. Given these classes, which color would these divs be? And these were the results of the poll. 44% of people thought that the first div would be blue and the second one would be red. 43% thought they'd both be blue. 9% thought the first one would be red, but the second one would be blue. And 4% thought both would be red. And this was really problematic. Max Stoiber is a technical guy. He's being followed mostly by other developers. Yet, on this very simple CSS question, the plurality of respondents got it wrong. Now, I don't point this out to poke fun at anyone. I'm certainly not trying to trivialize anyone's knowledge for having such fundamental gaps. The reality is everyone has gaps. I almost exclusively use visual Git editors because the commands for Git drive me insane. So what causes bad CSS? Often it's a lack of knowledge. So let's take a look and get back to the beginning and learn how CSS applies its styles. Above all else, anything that is marked important will override anything else that is not. So if you have a heading 1 with a text align center important, without an important, you can't fix this. And I bring this one up because this exact code was something that plagued me at one of my recent jobs when I first was being onboarded and asked to help the full stack team debug some of their style issues. Next, the browser considers selector specificity. I tend to think of selector specificity like a version number. Although there have been several models pointed out in the past, some referencing poker, some referencing Star Wars, the version number always made sense to me. In this case, we can look at it as A.B.C.D. At that highest level, at the highest one dot you can get, would be an inline style. For B, the specificity counts the number of IDs in a CSS selector. For C, the specificity is determined by the number of classes, pseudo-classes, and attributes in a CSS selector. And then finally at D, it counts the number of elements and pseudo-elements in a selector. And I think the reason that the versioning metaphor resonates so strongly for me is because no amount of elements or pseudo-elements will be able to override a single class, just like no amount of classes will ever override a single ID. So let's take a look at some examples. So here in this div where we're using inline styles, we have the maximum possible specificity of 1.0.0.0. Next, we just have a selector with two classes, 0.0.2.0. And over here, we're leveraging an element with a class, giving us a 0.0.1.1. And then over here, we have an ID giving us the 0.1.0.0. And then putting a class chained onto an ID gives us 0.1.1.0. These all seem pretty straightforward and simple, but let's look at something a little bit more complex. Here we have a before element that is being styled when a footer is hovered that is inside of an element with an ID of Mark 1 and that also has a class of suit that is within an element with the ID of Iron Man. This leads to a specificity that is very high and very arbitrary of 0.2.2.2. Now this looks a little absurd, but the reality is before a lot of different CSS approaches had been adopted, this was not that uncommon of a way to approach styling your CSS, targeting something like your footer and then drilling down into specific links. Next, CSS is going to take into consideration the sort order. Given two or more selectors of equal weight, the last declared style is what will get applied. So in this case, the background color of 00FF00 would be the background color that ultimately gets rendered. And then finally, in many cases, for many properties, CSS will choose to inherit undeclared styles from an ancestor. So in this case of a paragraph tag, by default, its color is set to inherit. If the color of the HTML element and nothing between there is set would be this FF00FF, the paragraph would pick up that color. So now let's pull all of this together and look at an example of just a little bit of HTML and some CSS and how we may run into some hiccups with what we get versus our expectations. So on this element, we can right away assume that one, the text is going to align to the right. We have an inline style. Nothing should be overriding that. We're explicitly telling it that we do not want a border, and we can know by the fact that it is tied to the Ant-Man ID that its color should be red. But of course that's not the case. So we look at the code again. And it can be really frustrating trying to figure out what exactly is going wrong. But then when we take a look at the broader CSS file, we take a look at the code that wasn't written for this specific instance. Code that's existed for years. Code that was written for a specific project at a specific time that could not have anticipated the needs that you have now. In here, we have a body with the color of purple. That's not really causing an issue. But for some reason, we have decided that the heading 1 should have this important text-aligned center. More likely than not, a developer ran into a similar specificity issue, gave up, marked it as important, and decided they'd fix it later when they had time. And spoiler alert, you never have time. But we also see that there is a statement that says anything that's inside of an Avengers class that's an H1 has a border bottom on it. And that anything that's inside of the hero ID with it that's an H1 is green. So in these two instances, it can be really frustrating to try to figure out what is overriding Ant-Man, because you look at it and the ID is very specific to Ant-Man. But when you look at the broader CSS, what you have to remember is that it's not about what elements are assigned to the specific DOM node. It's about the selector of the statement as a whole. So in this case, hero H1 has a specificity of 0.1.0.1, whereas Ant-Man alone just has a 0.1.0.0. And this is really just a micro example. This is nothing compared to some of the legacy CSS that I have seen for various clients. So we kind of know the problem. How do we write things better, though? Well, to start, you need to define and agree upon a CSS architecture that makes code easier to read, easier to scale, easier to maintain, and provides a predictable application of styles. So it's important to note that whatever your choice, you need to stick to writing whatever architecture is chosen. Everyone has coding preferences, but this is really a team decision. You're going to want to write your CSS for systems, not for pages. The web is a very different place than it was back in the 2000s. Everything from blogs to social media companies are really approaching a more componentized version of the web where they are aligning their content with UI components to render a page. And then you'll also want to write CSS in a way that mitigates unintentional specificity collision. So let's take another look at that example, and let's graph the specificity. So at the very left, we have the location in the style sheet. So starting off, we have a pretty low selector specificity. And as we move down the statements, we see a bit of a peak, and then a dip, and then another peak. This would mean that where we have that dip, things that came before it may overwrite it just by having a higher specificity. Now, what if we were to apply this to a much bigger CSS style sheet? The specificity map might look something a little bit more like this. And I feel like Harry Roberts said it best. It doesn't matter how well considered your source order is, how well you're utilizing the cascade, what naming conventions you used. Specificity can undo everything. So let's talk about some strategies. One that has gained a lot of movement in the last few years is CSS and JS. And a good example of this type of approach is styled components. So using this approach, your HTML, CSS, and JavaScript are bundled together more like how they would be for a common component. All of your CSS is kind of contained in the same file as your markup. This has some advantages. For starters, it really only loads the CSS that you're using, which is really great to handle some dead code elimination. Most of us have had CSS style sheets that include a lot of styles that are no longer used, but we also don't feel comfortable removing in case that one page we don't know about is still using them. A big benefit that I love about this approach is that you get to share your variables with your JavaScript. This can be super useful, especially in highly interactive components. And it's easy to ship, package, and be consumed by other sites and apps. However, it does have some drawbacks. Not all coding architectures rely on JavaScript to generate your HTML. And while it's great that you don't have to pull CSS that isn't being used onto the page, it also means that you don't really end up with a single style sheet that gets cached throughout the experience. And then from my experience, it is hard to exit from this strategy once you go down this path. So another option and another strategy is called inverted triangle CSS. This one was coined by Harry Roberts, and he recognizes it as one of the best approaches to build maintainable CSS by making sure the application of styles flows consistently. When he kind of coined ITCSS, he defined 3 key metrics: reach, specificity, and explicitness. So we would always want to err where things that have the broadest reach would be at the top of the style sheet, and things that would impact the fewest HTML elements would fall at the bottom of the style sheet. Similarly, we would want to paint with a broad brush, assigning many styles to a broad set of components at the top of the style sheet, and be very precise with what we're changing at the bottom of the style sheet. And at the top of the style sheet, we would be very general with our selector specificity favoring low specificity, but at the bottom, we would favor high specificity. So to kind of accomplish this, what he recommends is breaking the CSS into different layers. He chose 7. For me, when I'm working with this model, I tend to fall to 8. Really, this is one of those things that is sort of application and scenario dependent, and is one of those decision points that you get to make with your team. It's not necessarily about having the exact layers so much as defining where which pieces of code fall within your style sheet. So at the top, we would hold a settings layer. For us, we used preprocessors, and that would mean that we would define a lot of our variables and maps up here in the settings. This is really great for handling a lot of design token things like fonts, colors, spacing, declarations, etc. Then next, we defined a tools layer, also part of the preprocessor. And in this case, we stuck with functions and mixins. And then at the third layer, we started to apply some very generic styles. We would load in our font face declarations, and we would apply the CSS reset. And then we would start to look at the base HTML elements themselves: anchors, paragraphs, forms, etc. One particular hang-up with this layer that should be addressed is input styles. Input styles are really the only HTML element where the attribute radically changes how it is rendered to the user. So there are two acceptable ways to really code the input selector. One is just input. The other is using the attribute defining the type. If you chain them together, you risk accidentally overwriting styles in the elements layer with things that may come after the elements layer due to having a specificity of 0.0.1.1. Most things in the element layer only have a specificity of 0.0.0.1, but having a specificity of 0.0.1.0 is okay, because if it matches any of the following layers, the thing that comes last wins. The next layer that we started to use was where we felt we needed to inject kind of our own thing, and that's what we call the bits layer. For us, the bits layer resolved a really interesting challenge. We would have things that visually we would want to look like an HTML element, but semantically we would need to choose a different one. So this could be a designer saying that the page layout needs to look like this, but understanding that from an accessibility purpose, we need to make sure that the headings are properly marked up. This could be something like knowing that we would want to code something as a list, but visually we would want to nullify all of the basic bullet points that would come because we were going to style them later with something further down the line. This really helped just resolve that place where we needed an element that was a different element than what we were representing with the class. And then we would also have the object layer. We mostly leveraged that for layouts and things that weren't very well styled beyond spacing and positions. And then we began working with what people traditionally think of as components. And then finally, we had a utilities layer where we would be really precise with everything that we were changing. When I'm working with this utilities layer, I even advocate for adding important onto the utilities. Because when you align to this model, where the utilities are the last part of the file, you should have confidence when you give something a class of text center that it's going to be centered. So then, like, looking at all of these different layers, we would import the various layer files into a combined SAS file, just making sure that we kept all of the components above the utilities, all the objects above the components, etc., etc. Between the layers, it shouldn't really matter which component comes first, because you shouldn't run into situations where you have collision between the components. So some of the pros that I like about this approach is it really doesn't care how it gets generated. It's more about aligning to a methodology of source order and specificity than it is about how to get the CSS onto the page. I really like that it embraces the cascade. I know a lot of developers dislike the cascade, but it's an intentional feature of CSS, and it's nice to see an architecture that embraces it rather than fights against it. So some of the cons. One of the big cons is really going through that mental brain work of figuring out what layer does this thing belong to. And another con is that it can be really limiting sometimes, because in order to align to that inverted triangle model, you would want to make sure that you don't have duplicate classes, or that you don't have different classes from the same layer on the same element. And this could be kind of a weird scenario if you had something that both acted as a child of one element, but a wrapper for another. Most of the time you can resolve this by adding another element. But then there's another movement that is kind of gaining steam. And one that I've been a fan of for about a year now, and that is utility first CSS. And the idea here is to cut down on the number of component classes that you would have in general, and to really focus on defining your utilities, using the sort of design tokens that you would have with your design team. So you would create a utility class for every style that could exist on a component. And I felt this was a really interesting approach because I was really doing this to a bit when I was using ITCSS anyway. And it also has this, specifically Tailwind has this apply functionality. Tailwind being probably the most recognizable utility for CSS framework that really allows you to create these component classes by just combining a set of utilities. So this definitely has some pros. It is less CSS repetition. It embraces the restraints with the defined design tokens. Changes that fall within like the design specification are really easy to make. And I think it's a pro that I consider it compatible with ITCSS. Where it can get a little dicey, animations, transitions, and pseudo elements can be tricky to utilize, but this can be mitigated through the tools like Tailwind's apply to create components classes when necessary. And I almost struggle to call this a con, but less CSS code translates into more HTML code. So, another strategy to consider is really picking a naming convention. So if you're not using a sort of CSS and JS approach, you are going to have to pick a way so that your developers are able to easily understand what the classes are doing. As an example of this, I'm going to reference BEMIT. BEMIT is a combination of BEM, block element modifier, with some ITCSS prefixes and media query suffixes. This was another creation by Harry Roberts to create a more consistent naming convention for those that would follow the ITCSS model. So for layer prefixes, it's usually something as simple as adding the first letter of the layer to the beginning of the class. So for us, that meant B for bits, O for object, C for component, or U for utility. And then for breakpoint suffixes, the suffixes signify class styles apply at a given breakpoint. So by defining a few different named breakpoints, we could have something like utilities and then define exactly when those get applied and at what breakpoint. So here's kind of like a normal BEM example. And here is what it looks like following BEMIT. You can quickly scan through the code and see what layer each of the classes from the ITCSS model would fall. And I think this is a really good approach to basic class naming conventions. But depending on your needs, it's probably also worth considering application or brand name spacing. So, especially if you're part of a larger company that has multiple brands and sub-brands, you may have a parent organization that has some base level styles that apply everywhere, but sub-brands that have some unique color palettes or fonts or spacing that kind of act as a supplement. So kind of extending just on top of the BEMIT model, we would inject an application prefix between the ITCSS layer and the block. So in this case, we might have a component that is a Marvel brand component. We could also have something that is specifically an Avengers brand component, and maybe even something that is specifically an Iron Man component. Being able to reuse some of these namespacing across multiple properties can be really helpful to reduce the amount of work and maintenance that your dev team has to do. So in this case, for an Iron Man page, we can leverage things like the bear bit class from the Marvel brand component. Similarly, if we have a similar page layout for all of the Avengers, we can pull in that object and really just utilize the Iron Man namespace for the specific headings, which may result in different Iron Man specific fonts and colors. So you may be asking yourself, with all these different approaches, how do you decide which approach and architecture to adopt with your team? Well, it's really important to know your constraints. Some applications are using radically different JavaScript approaches. You know, some are built in a .NET web form still, built years ago, but still being maintained and are crucial to business today. Some are compiled using CMS templates. And an unfortunate truth is that sometimes the code that you're working with kind of resides inside of a third-party black box. And as it turns out, not all companies are going to renegotiate vendor contracts and re-architect their code base. So in one instance, I could control the final markup, but I couldn't control how that markup got generated. And I could control what style sheets were included on a page. So with those limitations and that opportunity, I tended to err towards a more traditional CSS approach, but also wanted to make sure that we solved the same problems. So for me, that meant leveraging ITCSS and using a heavy utility layer to kind of try to cut down on some of the code duplication. But in another instance, I could control the complete end-to-end experience. And in that environment, it was very fast-paced. We had an application that we needed to deliver. It was updated rapidly, and the changes were, they felt pretty nonstop. For this instance, what I had chosen to do was leverage a CSS and JS solution such as styled components. It was easier to kind of maintain all of my isolated components, and it was really easy to package up in NPM and consume within different applications. The reality is it really just depends. And even once you have chosen that CSS architecture, you're not really done, because you're never done. Once implemented, your CSS must continuously be groomed and modified. So here's some tips that I have that have been useful for me. You're definitely going to want to implement a versioning and deprecation strategy, because you don't want to let unused code remain indefinitely. You know, this is one of the advantages of the CSS and JavaScript approach. This kind of gets taken care of a little bit for you, but if you're having to reuse or to use a more traditional style, it becomes more important that you clean up that bloat that you're serving to your end users. Do propose modifications to the architecture as needed. Nothing is sacred. We are everything we build will be deleted or rewritten one day. But don't surprise your team. In order to be successful, you guys have to work together. So in conclusion, you're really going to know that you're successful when your newly onboarded team member can quickly move throughout the code base, and they know where to go to change styles, and they know how to make modifications without surprises. I do want to point out a note of caution. The flexibility of CSS means that any defined architecture is only as stable as the team's willingness and ability to follow it. Questions? That's right, this isn't live, this is a pre-recording. So I will go to the chat, hopefully answer any questions that you guys may or may not have. And then we will be back again to see the next session. Thank you, everyone. It's great being here. Happy to be here. I hope everyone's staying safe with this pandemic, and thank you very much. Bye.